In section 1.4, part 2, we continue solving our radical equations. We have 2 more examples involving radicals before we move on to other types of equations. So example 4 has the square root of 3x plus 1 minus the square root of x minus 1, and that's equal to 2. So when you start to solve equations, one of the things you should do is make sure you start to notice why it's different from the previous example or the previous problem we worked. This one's different because it has 2 separate radicals, and that's the first time for us. We're still going to follow those 5 steps. Step 1 was to isolate a radical. So we're going to pick one of these and move it to the other side. It makes most sense to move the negative one. So that would give me the square root of 3x plus 1 is equal to 2 minus the square root of x minus 1. Sorry, that should be a plus. When I move the radical to the other side, the entire term becomes a positive square root of x minus 1. Okay, what you're going to notice is we have a single term on the left side. We have 2 terms on the right side. So when we go to FOIL it, when we go to square it, we're going to need to FOIL. We're going to square both sides. That's going to give me 3x plus 1 on this side. On the right side, I'm going to write it out. It's 2 plus the square root of x minus 1 times the quantity 2 plus the square root of x minus 1, and that'll help us get it FOILed correctly. So we haven't done anything to the right side yet. We're now going to FOIL to square. So the first term would be the 2 times the 2, which gives me 4. The outside term is this 2 times this x minus 1 in the radical. So this is going to be 2 times the square root of x minus 1. The inside term is going to yield the same exact thing. The square root of x minus 1 times 2 is 2 times the square root of x minus 1. The last term is the radical times itself. So that's going to eliminate the radical and just give me x minus 1. Again, we did the 2 times the 2, which gives me the 4. I have 2 times the radical on the outside. I have 2 times the radical on the inside. That's my 2 middle terms sitting here. And then finally, the radical times itself just gives you an x minus 1. Let's clean that up before we go any further. So we're going to collect like terms. I have a 4. I've got a minus 1. That's going to give me a 3. I'm going to bring this x to the front just because it looks better there. I can add my 2 radical terms together by adding their coefficients or the numbers in front. That's going to give me 4 times the square root of x minus 1. Unfortunately, we're at that step 3. Step 3 said that if you still have a radical, let's repeat steps 1 and 2. So back to step 1, we're going to isolate the radical. So that means we need to get this radical all by itself. So I'm going to go ahead and move this 3 and this x over to this side. So we'll subtract the 3 and we'll subtract the x. That's going to give me 2x minus 2 is equal to 4 times the square root of x minus 1. At this point, we're going to square everything again to isolate. We're going to square everything again to get rid of the radical. I'm not going to worry about this 4. If I tried to divide it out, I'd get fractions, and I don't like to work with fractions if I don't have to. So we're just going to square everything right here. On the right side, we're going to get 16 times x minus 1. On the left side, that's 2x minus 2 times 2x minus 2. And I ran out of room, so I'm going to take that over here. When I FOIL that out, I'm going to get a 4x squared. The outside term will give me 4x, and so will the inside term. So that's going to give me minus 8x. And the negative 2 times the negative 2 at the end of this thing is going to give me a plus 4. On the right side, I'm going to go ahead and distribute that 16. So I'll have 16x minus 16. And again, I noticed that I have a quadratic equation. I've got an x squared sitting there. That means I need to set it all equal to 0. This time we're going to move everything to the left side because that's where the x squared is. So we're going to bring over the 16x and that negative 16. So we'll subtract 16x, we'll add 16. That's going to give me 4x squared minus 24x plus 20 is equal to 0. Now we're stuck with the factoring. Again, it's always quicker to factor. The first thing we'll notice is that all 3 terms will divide by 4. So let's divide that out of there because it's equal to 0. We can do that. We're going to divide everything by 4. So that'll give me x squared minus 6x plus 5 is equal to 0. And that factors of 5 that add to 6 are 5 and 1. So I'll have x with a 5 and x with a 1. And again, because we're adding, they both are going to take that minus sign and we're going to add to the negative 6. Solving each of these, you're going to get x equals 5 and x equals 1. This is one of the longest problems we do in our course, is this double radical problem. We need to check both answers to make sure they do both work and that we don't have one of those extraneous solutions. So let's plug the 5 back in. So 3 times 5 is 15. 15 plus 1 is 16, and the square root of 16 is 4. So when I plug in the 5, I get a 4 in that first radical. 5 minus 1 is 4, square root of 4 is 2. And sure enough, 4 minus 2 is 2. So this one works, it's good. We've checked it. Now let's check the 1. So 3 times 1 is 3 plus 1 is 4. Square root of 4 is 2. 1 minus 1 is 0. Square root of 0 is 0. And sure enough, 2 minus 0 is 2. They both work. That's actually unusual. Usually only one of them works, but in this case, they both work. So we've now solved an equation that has 2 radicals in it. So let's do one more before we're done solving the radical equations. This is example 5. And of course, each example is slightly different and has a twist. That's why we picked these examples to work through. So example 5, we have the quantity 5x minus 1 raised to the 1/3 power, and that's equal to 2. And we want to solve that. Well, you're thinking, wait a minute, that's not a radical. But I'd like to remind you of one of your exponent rules. So if I have m raised to the 1/n power, that's the same thing as the nth root of m. So in other words, if you have an exponent that's a fraction, you can rewrite that as a radical, where the denominator on the fractional exponent is the root or the index on your radical. So what that really means is back over here, that 1/3 is telling me that I have the cubed root of 5x minus 1. And that's going to be equal to 2. And now we're right back solving what we were solving before with the radical. So the radical is by itself. That was step 1. We're going to raise both sides to the same power. So that's a 3. So that's going to give us the cube, undoes the cube root, which gives me 5 minus 1. To the 3rd power is 8. And then this is linear. There's no x squared. So you can just go ahead and move the 1 and divide out the 5. So we move the 1 and you get a 9. And then you're going to divide out the 5 and get a 9/5. You can check it really quick. 9/5 times 5 is 9. 9 minus 1 is 8. The cube root of 8 is 2. So it definitely works. And that's how you solve different radical equations.